Now, in this lecture, we will find out the radius of the semicircle. In the drawing, we have triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. We also know that side AB equals to 3 units in its size, and the line segment DC, this line segment equals to 1 unit in its size. And we also know that side AB of triangle ABC is tangent to the semicircle at point B, and side A, line segment AE, is tangent to the semicircle at point E, and inside the triangle we have a semicircle. The semicircle is inscribed with a triangle, and we want to find out the radius of this semicircle. So, in order to find out the radius of the semicircle, I will present to you rule number 1, or two tangents theorem. According to rule number 1, or two tangents theorem, the length of two tangents from a common external point are equal. So, I will read rule number 1, or two tangents theorem again. According to rule number 1, or two tangents theorem, the length of two tangents from a common external point to a circle are equal. So I will read rule number 1 again, or two tangents theorem. The lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1, or two tangents theorem? The meaning of rule number 1 is that if you have a circle, this circle, and we have a common external point P. This point P, is an external point because of the fact that point P is not located inside the circle nor on the circle itself, but it is located outside the circle. Therefore, it is defined as external point to this blue circle, and if from the external point, point P, we will draw two tangents to this circle. So the first tangent will be this tangent, we define the touching point between the first tangent and the blue circle as point A, and we will also draw a second tangent to this circle, and we define the touching point between the second tangent and the circle as point B, and as you can see from the drawing, the length of the first tangent is PA, and the length of the second tangent is PB, and according to rule number 1, the length of two tangents from a common external point to a circle. So here we draw the two tangents from a common external point, point P, and according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. That is to say, the length of the first tangent is equal to the length of the second tangent. That is to say, PA equals to PB. That is actually rule number 1 of two tangents theorem. Okay, so whenever you draw two tangents from a common external point, whenever you draw two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this case, PA is equal to PB because we draw two tangents to the blue circle from a common external point, point P. Okay, so that is the meaning of two tangents theorem. Okay, so we can implement the two tangents theorem in our drawing. Because in our drawing we have an external point, point A. It is external point in relation to the semicircle, and from point A we have two tangents to this semicircle. The first tangent is AB, and the side of AB is 3 units, and the second tangent to this semicircle is AE. So according to rule number 1, whenever you draw two tangents to a circle from a common external point, they are equal in their lengths. That is to say, AB is equal to AE, AB is equal to AE, according to two tangents theorem or rule number 1. But we know that AB equals to 3 units. It is given us in the question. So from this equality, we will derive that AE also equals to 3 units. AE also equals to 3 units. So this line segment equals to 3 units. In the next step, we'll define the center of this semicircle as point O. Actually, OB is the radius of this semicircle because of the fact that line segment OB starts from the center of the semicircle and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle, so we will call the radius of the semicircle as R. So OB equals to R because it is the radius of the semicircle. And OD, it is also line segment OD, it is also the radius of this semicircle because of the fact that it starts from the center of the semicircle and ends at point D, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle, so it equals to R. And we will also join points O and E together by a straight line. Actually, line segment OE this line segment OE is the radius of this semicircle because of the fact that line segment OE starts from the center of this semicircle. It ends at point E, that is a point on the semicircle itself. Therefore, it is the radius of this semicircle, so it equals to R. Okay. In the next step, I will present to you a new rule, rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will write rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn I read again. A tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have a circle and the center of this circle is at this point, and we will define the center of the circle as point O, and we also have a tangent to this circle. Actually, tangent AB, this tangent in the black color is tangent to the blue circle. At this point we define the touching point between the tangent and the circle as point M. Point M, it is actually also the point of tangency of tangent AB with the circle. Okay, point M is the point of tangency of tangent AB with the circle. Okay, and we have also radius that starts from point O and ends at point M. That is the point of tangency. It is R, the radius. So according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. Actually, this radius OM, is drawn to the point of tangency. It is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So I will repeat again. According to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. Actually, this radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius, that is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so that is rule number 2, and we actually can implement rule number 2 in our drawing, because in our drawing we have tangent AC. Tangent AC is tangent to the semicircle at point E. Point E is the touching point between the tangent and the semicircle, or point E is the point of tangency. Point E is the point of tangency of tangent AC with the semicircle. Point of tangency. Again, it is the point of tangency of tangent AC with the semicircle. And we actually have this radius OE is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency. I'll repeat again. The radius OE is drawn to the point of tangency, that is to say, to point E. Therefore, the tangent AC is perpendicular to this radius that is drawn to the point of tangency. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 2. So actually, angle OEC, this angle equals to 90 degrees. Therefore, triangle OEC is a right triangle. Okay, so actually the green triangle OEC, is a right triangle because it has one angle that equals to 90 degrees. So we'll focus on the green right triangle, triangle OEC. Okay? We'll focus on the right green triangle, triangle OEC. In triangle OEC, in the right green triangle, triangle OEC, it is a right triangle, therefore, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? The square of the hypotenuse in the right triangle, triangle OEC, actually the hypotenuse in the right triangle, triangle OEC is side OC. So it is actually the square of the hypotenuse is OC square. And it equals to the sum of the squares of the perpendiculars, that is to say, it equals to OE square plus EC square. We'll define EC as x, that is to say, EC equals to x units in its size. So I will repeat again, according to the Pythagoras theorem, in the right triangle, triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, OC square equals to OE square plus EC square. But what is the value of OC, or what is the length of OC? From the drawing, you can see that the length of OC, the length of the hypotenuse OC equals to R plus 1. Again, the length of the hypotenuse OC equals to R plus 1. So OC square will be equal to R plus 1 square. Okay? OC equals to R plus 1, therefore OC square equals to R plus 1 square, and it equals to OE square it equals to OE square OE equals to R, so OE square will be equal to R square plus EC square. EC equals to X, so EC square will be equal to X square. So in total we got that R plus 1 square equals to R square plus X square. So we will open the brackets in equation number 1, in this side of the equation number 1. R plus 1 square equals to R square plus 1 plus 2R according to the formula. according to the trigonometric, according to the formula that a plus b squared equals to a squared plus b squared plus 2ab, and it equals to r squared plus x squared. So here we have r squared in this side of the equality, and we have r squared on the other side of the equation number 1. So we can subtract r squared from equation number 1. Therefore, r squared will get cancelled. And what is left after we cancel r squared? What is left is it is actually one plus 2r equals to x squared. So we found out that according to equation number 1, 1 plus 2r equals to x squared. Okay, so in the next step we will focus on the right triangle ABC, the right big triangle ABC, and we will also focus on the small green right triangle OEC. Okay, so write it down. We will focus on triangle ABC and triangle OEC. And repeat again, we will focus on the right big triangle ABC, and on the green right triangle OEC. Okay. Actually, those two angles are equal to each other, they are both right angles. So we'll write down that angle ABC in triangle ABC equals to angle OEC in triangle OEC and they are both equal to 90 degrees. Okay, so angle ABC equals to angle OEC, and the both equals to 90 degrees, they are right angles. And this angle is a common angle, it belongs to both triangles, and this angle belongs to triangle ABC, and it also belongs to the green triangle OEC. So we write it down that angle C equals to angle C. It's a common angle that belongs to both triangles. And I'll repeat again. Angle C equals to angle C. It's a common angle that belongs to both triangles. And actually, those two angles are equal to each other. Angle VAC is equal to angle EOC, Those two angles are equal to each other according to third angle theorem. So I will write it down. Angle BAC in triangle ABC is equal to angle EOC in triangle EOC. And they are equal to each other according to third angle theorem. I will repeat again. Angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Or rule number 3 of third angle theorem. So according to rule number 3 of third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. I'll repeat on the third angle theorem again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of the third angle theorem? The meaning of the third angle theorem is that if you have two triangles triangle ABC triangle DEF. And those two triangles has two angles that congruent. This angle is alpha, and this angle also equals to alpha, so this is the first pair of angles that congruent, and they also have a second pair of angles that congruent, beta. This angle is beta, and this angle is beta, so this is the second pair of angles that congruent, and here is angle gamma, and this angle is angle theta. So if two triangles has two angles that congruent, alpha and beta, then the third pair of angles must also congruent. That is to say, gamma equals to theta. So according to rule number 3 of third angle theorem, angle gamma, this angle, equals to angle theta, to this angle. Okay, so we will prove that angle gamma equals to angle theta. Okay, so as you already know, the sum of the angles in any triangle equals to 180 degrees. Therefore, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. According to the rule that the sum of the angles in any triangle equals to 180 degrees, if you focus on triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. So I'll repeat again. The sum of the angles in triangle DEF also equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Okay, equation number 1 is the sum of the angles in triangle ABC. And equation number 2 is the sum of the angles in triangle DEF. Okay. So we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees. This is to say it equals to 0. So here we will add theta to equation number 3, and we will get that angle gamma equals to angle theta. So we proved that the third angle theorem is true, because we proved that angle gamma equals to angle theta. Here we proved that angle gamma equals to angle theta. So whenever we have two triangles that has two pairs of angles that are congruent, then the third pair of angles must also congruent, that is to say, angle gamma equals to angle theta. Okay, so we return to our drawing. So we actually proved that all three angles of triangle ABC congruent or equal to all three angles of triangle OEC. Therefore, we proved that triangle ABC is similar to triangle OEC we proved the triangle ABC is similar to triangle OEC according to angle similarity rule. I will repeat again. We proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of another triangle, then you prove actually that the two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to the great triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay, I'll repeat again. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. But what is the size of AB? AB equals to 3 units according to what is given us in the question. And what is the size of AC? AC is the hypotenuse of triangle ABC. The size of AC is 3 plus x. Okay? I'll repeat again. AB equals to 3 units, AC equals to 3 over x. And what is the size of OE? The size of OE equals to R, the radius of the semicircle. And what is OC? The size of OC equals to R plus 1. So in total we got that 3 over 3x equals to R over R plus 1. Here we cross multiply equation number 2. and we will get that three times r plus 1 equals to r times 3 plus x. I'll repeat again. We first multiply the equation number 2, and we got that 3 times r plus 1 equals to r times 3 plus x. So here we will open the brackets in equation number 2, and we will get that three times r plus 3 equals to 3 times r plus rx. Here we'll subtract 3r from equation number 2. So 3r will get cancelled. So what is left after we cancelled 3r? What is left? It is actually 3 equals to rx. Here we will divide the equation number 2, this equation, by x, and we will get that r equals to 3 over x. We found out that according to equation number 2, the radius of the semicircle equals to 3 over x. But we have already found out in equation number 1 that 1 plus 2r equals to x squared. So we can substitute r in equation number 1 by 3 over x, because r equals to 3 over x. So we get that according to equation number 1 plus 2r. 2r is 3 over x equals to x squared. So we found out that one plus 2 times 3 over x equals to x squared. Here 2 times 3 is 6, so we write it down. So here we will multiply equation number 1 by x. Actually, why we can multiply the equation by x? Maybe x is 0, and if x is 0, it is not allowable to multiply anything by 0. But as you can see from the drawing, x is EC, it is one side of the green triangle, and a side of a triangle must be a positive number, therefore it can never be 0. Therefore it is allowable to multiply equation number 1 by x. Okay? So we will multiply equation number 1 by x, and we will get that x plus 6 equals to x times x is x cubed. Here we will subtract x from equation number 1, and we will get that x cubed minus x equals to 6. Here we'll subtract 6 from equation number 1, and we'll get that x cubed minus x minus 6 equals to 0. So here we will subtract 2x squared from equation number 1, and then we will add 2x squared. Actually, minus 2x squared plus 2x squared equals to 0, and that is the reason that it is allowable to do this operation. So we will subtract 2x squared and then add 2x squared to equation number 1, and we'll get that x cubed minus 2x squared plus 2x squared minus x minus 6 equals to 0. I will repeat again, this expression equals to 0, therefore it is allowable to add 0 to any equation. And we know that minus x equals to 3x minus x equals to minus 4x plus 3x so we'll substitute minus x by minus 4x plus 3x, and we will get that x squared minus 2x squared plus 2x squared, that is 0, and instead of minus x we write down minus 4x plus 3x, that equals to minus x. Minus 6 equals to 0. So we substituted minus x by minus 4x minus 3x, and we got this expression. So here we will divide equation number 1 to 4. We'll divide the equation number 1 to 3 parts. This will be the first part. This will be the second part. And this will be the third part. Okay, and then we will take out a common factor from each part. Okay, so actually the first part of equation number 1 is x cubed minus 2x squared this is the first part on equation number 1. Equation number 1, x cubed minus x squared. We take x cubed, x squared as a common factor of this expression, and inside the brackets what will be left is from x squared what is left is x, and from minus 2x squared what is left is minus 2. So in total we got this expression that x cubed minus 2x squared equals to x squared times x minus 2. Then we take a common factor of the second part of equation number 1, 2x squared minus 4x the common factor of these two expressions will be 2x so what is left inside the brackets after we took 2x from this expression, what is left from 2x squared is actually x, and what is left from minus 4x after we took 2x as a common factor, it is actually minus 2. So in total we got that 2x squared minus 4x squared equals to 2x times x minus 2. Then we take a common factor from the first part of equation number 1, that is to say from 3x minus 6 and 3x minus 6, that is the first part of equation number 1. Here we take 3 as a common factor. So what is left from 3x after we took 3 as a common factor? What is left? It is actually x. And what is left from minus 6 after we took a common factor of 3? What is left? It is actually minus 2. So we got to this expressions. So we'll substitute those three original expressions for equation number 1 by those three expressions that equal to those three expressions, and we'll get that according to equation number 1, x squared times x minus 2 plus 2x times x minus 2 plus 3 times x minus 2. Okay, I copy those three expressions in one line. That is actually equation number 1. We substituted the original equation number 1 by those expressions that equals to equation number 1. Here we take a common factor of x minus 2 out of this expression, and we will get that so x minus 2 is a common factor, what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 3, all equals to 0. So we got this equation number 1. Here we actually have two solutions that are possible. Either x minus 2 will be equal to 0, or either the quadratic equation will be equal to 0. So I write down the two solutions that are possible. The first solution is that x minus 2 equals to 0. And the second solution is that x squared plus 2x plus 3 equals to 0. Okay? So those are the two solutions that are possible for equation number 1. We will focus on the second solution. The second solution is a quadratic equation. So we need to solve the quadratic equation in order to find out the value of x. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x by using a special formula for x. X actually equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay? So our specific quadratic equation, what are the coefficients of our specific quadratic equation? X squared plus 2x plus 3 equals to 0. Here the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to 3. Okay? So we will put the data, the values of the coefficients in the equation for x in order to find out the value of x. And we will get that x equals to minus b, b equals to 2, so minus b will be equal to minus 2, plus minus root of b squared. B is 2, so b squared is 2 squared is 4, minus 4 times a is 1, so 4 times 1 is 4, times c is 12, so it is minus 12 over 2 times a, 2 times 1 is 2, so in total we got that x equals to minus 2 plus minus, and 4 minus 12 is minus 8, and because of the fact that there is no root for a negative number, so the quadratic equation doesn't have a solution because we are stuck here. There is no root for negative numbers. Therefore, the second option, the second solution is not correct, and we left only this with the solution that x minus 2 equals to 0. So if x minus 2 equals to 0, x minus 2 equals to 0, if x minus 2 equals to 0, then x equals to 2, we have already found out that according to equation number 2, r equals to 3 over x, r equals to 3 over x, so we can substitute x by 2 because x equals to 2, so r equals to 3 over x is 2, so r equals to 3 over 2 units, so the radius of the semicircle is either 3 over 2 units or it equals to 1.5 units. So I'll repeat again. We found out that the radius r of this semicircle equals to either 3 over 2 units or to 1.5 units. Okay? So now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle, and we know that here we have a triangle ABC that is a right angle. AB equals to 3 units. Angle ABC equals to 90 degrees. Line segment DC equals to 1 unit, and we want to find out the radius of this semicircle. So I presented to you rule number 1. According to rule number 1, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this blue circle and we have external point P, and from the external point P we draw two tangents to this circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Therefore, whenever you draw from an external point of a circle 2 tangents to that circle, then the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB. And actually, we implemented rule number 1 in our drawing, because here we can implement it in our drawing because we have here point A is an external point in relation to this semicircle, and from the external point A we have two tangents to this circle. The first tangent is AB, the second tangent is AE, and according to rule number 1, the lengths of two tangents from an external point of a circle are equal to each other. That is to say, AB equals to AE. AB equals to AE, according to rule number 1, but we already know that AB equals to 4 units. It is given us in the question. So AB equals to 4 units, and from this equality we will derive that AE also equals to 3 units. Okay, and then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and tangent AB is tangent to this blue circle at point M. Point M is the point of tangency. Then the tangent AB will be perpendicular to this radius that is drawn to the point of tangency. That is to say, this radius is drawn to point M. That is the point of tangency. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, that is the explanation of rule number 2. And we actually implemented rule number 2 in our drawing. In our drawing, we have tangent AC that is tangent to this semicircle at point E. Point E is the point of tendency of tangent AC with the semicircle. And we have the radius OE. This radius is drawn to the point of tendency. That is to say, it is drawn to point E. That is the point of tendency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And because of the fact that angle OEC is a right angle, therefore the green triangle OEC is a right triangle. So we will focus on the green right triangle OEC. According to the Pythagoras theorem, in the right green triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. Okay, but what is OC? What is the size? What is the value of OC? The value of OC is actually, as you can see from the drawing, it is R plus 1. OC is R plus 1, so OC square is R plus 1 square. OE is R, so OE square is R square. And EC equals to X according to our definition, therefore EC square equals to X square. So in total we got that R plus 1 square equals to R square plus X square. According to the Pythagoras theorem, we open the brackets in this expression. So R plus 1 square equals to R square plus 1 plus 2R, and all equals to R square plus X square. We subtracted R square from equation number 1 and we got that 1 plus 2R equals to X square. Okay? So then we focus on the right triangles, triangle ABC, and the green right triangle, triangle OEC. We proved that those two triangles similar to each other. Why they're similar to each other? Because first of all, we have those two angles that are equal to each other. They are both right angles. Therefore, they are equal to each other. That is to say, angle ABC equals to angle OEC equals to 90 degrees. We also have a common angle. Angle C is a common angle. It belongs to both triangles. So we can write down that angle C equals to angle C is a common angle. And we also proved that those two angles are equal to each other according to third angle theorem. Okay, angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3? The meaning of rule number 3 of third angle theorem is that if we have those two triangles, triangle ABC and triangle DEF, and they actually have two pairs of angles that are equal to each other. Those two angles are equal to each other, they are both equal to alpha, and those two angles are also equal to each other, they are both equal to beta. So we have two triangles with two pairs of angles that are equal to each other. Two pairs of angles that are equal to each other. So if this is the situation, then the third pair of angles must be also equal to each other. That is to say, angle gamma must be equal to angle theta. We proved that the third angle theorem is true by the following proof. We actually know that the sum of the angles in any triangle equals to 180 degrees. The sum of the angles in triangle ABC is alpha plus beta plus gamma, and it equals to 180 degrees. So equation number 1 states that alpha plus beta plus gamma, that is the sum of the angles in triangle ABC, equals to 180 degrees. And the sum of the angles in triangle DEC is alpha plus beta plus theta, as you can see here. Alpha plus beta plus theta. Alpha plus beta plus theta is the sum of the angles in triangle DEF, and it must be also equal to 180 degrees. So we have two equations for the sum of the angles in two triangles. We subtract equation number 1 from equation number 2. So here alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees is 0, so we got that gamma minus theta equals to 0. We added theta to equation number 3, and we found out that angle gamma equals to angle theta. Actually, we proved third angle theorem that angle gamma equals to angle theta. We actually proved that if we have two pairs of angles that are equal to each other, here we have angle alpha that equals to angle alpha. That is the first pair of angles that are equal to each other. We have also the second pair of angles that are equal to each other. In both those two triangles, we have angle beta. We proved that the third pair of angles must be also equal to each other. Actually, we proved that angle gamma equals to angle theta. In this way, we proved that the third angle theorem is true. And we will return to our original drawing. We proved actually that all three angles of triangle ABC are congruent to all three angles of the green triangle, triangle EOC. Therefore, we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. From the fact that those two triangles can go into each other, we will conclude that AB over AC equals to OE over OC. Again, AB over AC in triangle ABC equals to OE over OC in triangle OEC. And what is AB? AB equals to 3 units. AC equals to 3 plus X. And what is OE? OE equals to R. And OC equals to R plus 1. So in total, we got that 3 over 3 plus X equals to R over R plus 1. Here we cross multiply the equation number 2. And we got that 3 times R plus 1 equals to R times 3 plus X. We open the brackets and we got that 3R plus 3 equals to 3R plus Rx. We subtracted 3R from equation number 3 and we got that 3 equals to Rx. We divided equation number 2 by X. It is allowable to divide equation number 2 by X because X is a side of a triangle. It can never be 0, therefore it is allowable to divide equation number 2 by X. So we divided equation number 2 by X, and we got that the radius of the semicircle equals to 3 over X. Okay, but we already found out in equation number 1 that 1 plus 2R equals to 2X. So we can substitute R in equation number 1 by 3 over X because R equals to 3 over X. So we substituted R by 3 over X in equation number 1 and we got to this equation that 1 plus 2 and instead of R we substituted R by 3 over X, it equals to X squared. So here we have 1 plus 2 times 3 over X equals to X squared. 2 times 3 is 6, so we got that 1 plus 6 over x equals to x squared. We multiplied equation number 1 by x, and we got that x plus 6 equals to x cubed, because x squared times x is x cubed. We subtracted x from equation number 1, and we got that x squared times x equals to 6. Then we subtracted 6 from equation number 1, and we got that x cubed minus x minus 6 equals to 0. We know that minus 2x squared plus 2x squared is 0. So we can add 0 to any equation. Therefore, we added to equation number 1 0, and the 0 is minus 2x plus 2 minus 2x squared plus 2x squared. Okay, and we got that we found out that x squared and minus 2x squared plus 2x squared is 0. Minus x minus 6 equals to 0. Then we substituted minus x by minus 4x plus 3x, because minus x equals to minus 4x plus 3x. And we got this equation. After we substituted minus x by minus 4x plus 3x, we divided equation number 1 to 3 parts, and we took out a common factor from each part. Okay. So the first part of equation number 1 is x cubed minus 2x, and the common factor that we took from x cubed minus 2x squared is x squared. And if you took x squared as a common factor from this expression, inside the brackets you will have x minus 2, and we took a common factor from 2x squared minus 4x, the common factor is 2x, and if you take 2x as a common factor from this expression, you will get inside the brackets x minus 2, and we took a common factor of 3 from this expression, 3x minus 6, and if you took 3 as a common factor from this expression, you will get inside the brackets x minus 2. So in total, those 3 expressions are equal to each other, so we added together those 3 expressions, and we got equation number 1. This is equation number 1 after we substituted those 3 expressions by the identical expressions, and we got this expression. Here we can take a common factor of x minus 2 out of these 3 expressions, and after we took a common factor of x minus 2 out of these 3 expressions, we got this expression that x minus 2 times x squared plus 2x plus 3 equals to 0. Here we have 2 solutions to this expression, equation number 1. The first solution, that is either x minus 2 equals to 0, and the second solution is that this quadratic equation x squared plus 2x plus 3 equals to 0. Okay, and we actually focused on the second solution. We focused on the second solution of equation number 1, that the quadratic equation x squared plus 2x plus 3 equals to 0. We solved this quadratic equation according to the general formula for quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. Okay, this is the special formula for x. We put the data inside this equation for x. We know that the coefficients of our specific quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation for x, and we found out that x equals to minus b, b equals to 2, so minus b is minus 2, equals to the square root of b squared, b equals to 2, so b squared is 2 squared, 2 squared is 4. And minus 4 times a is 1, c is 3, so minus 4 times 3 is 12. So in total we got this expression that x equals to minus 2 plus minus root of minus 4 minus 12 over 2. 4 minus 12 is minus 8. So we got this expression that x equals to minus 2 plus minus root of minus 8. But because of the fact that the negative number doesn't have a root, therefore we are stuck here. We can conclude that this quadratic equation has no solution. And because of the fact that this quadratic equation has no solution, this option is not correct. So we will abandon this solution and we will left only with the solution that x minus 2 equals to 0. If x minus 2 equals to 0, then x will be equal to 2. And we have already found out that the radius of the semicircle equals to 3 over x. And we know that x equals to 2, so we can substitute x by 2. And we got that r equals to 3 over 2. So the radius of the semicircle equals to either 3 over 2 units or it equals to 1.5 units. I will repeat again, the radius of this semicircle equals to either 3 over 2 units or it equals to 1.5 units. Okay, thank you very much.